All right, here's another video. I'm going to finish these notes for you so you can work on a worksheet. Basically, what this is saying is write an equation with the given information. $950 is deposited into an account getting 2.5% interest compounded annually. So using this formula that we learned, all right, P is the amount you're putting in, R is the rate, N is the number of times you're compounding the interest per year, and T is the amount of time in years that you're compounding it. So I'm just going to kind of keep this here because I'm going to refer back to that every single time I make one of these things up. So I got $950 going in at 2.5% as a decimal, 0.025. Compounded annually tells me N equals 1. So that's going to be 1. And then this is just coming up with a model. So my answer would just be 950 times parentheses 1 plus 0.025 over 1 to the 1t power. All right, next one. 2,300 deposited into an account getting 11% compounded daily. Well, that just told me N is 365. The rate being 11% tells me R is 0.11. So then I just go straight into the formula and I do this. 2,300, 1 plus 0.11 over 365 to the 365t power. Once again, that's the answer to number 2. All right, moving on, number 3 and 4. A little bit different. You're not working with money, but it's the same concept, okay? In 1990, there were 3 bald eagles. That's your initial amount. 3 bald eagles is your P. Each year, your N is going to be 1. The number of bald eagles increased by 4.2%. So this is what you got. So 1990 really doesn't come into play. It's just kind of there. But you got 3 bald eagles to start. You got a rate of 0.042 or 4.2%, compounding every year. So it's just like your simple exponential growth equation. The next, you purchase an antique cabinet for $400. All right, you get 6% interest, 6% increase per year. Once again, N is 1. Simple interest increase there. So again, if I was to ask you, looking back at these, and I was to ask you, like, how much money do you have in this account after 10 years? Well, all you would do then is you would plug in 10 for T. That's it. And you'd plug it in your calculator, you'd get an answer. All right, so that's all you're thinking for these. Same thing here. If you were going to ask, like in number 3, how many bald eagles are living in Illinois in 2000? Well, if you're talking about 2000, you're going to say, well, that's going to be 10 years after, so you would plug in 10 for T. And that's a little bit tricky. We'll talk about that when we get to those problems. But we don't care about that right now. We're just coming up with a model, so let's continue that. In 2000, there were 8,000 polar bears, initial amount. The number of polar bears is decreasing at a rate of 1%. So that's 0.01, but it's negative because it's decreasing. And you're decreasing at a rate per month. So that just told me N is 12. So I got 8,000. So A equals 8,000. 1 plus 0.01, but again, negative 0.01 over N to the NT. And the negative rate is simply just going to make this part inside a fraction. If that part is a fraction, that indicates decay, and that's really all we're worried about. But that's my model for that particular problem. Number 6, you bought a car in 2006. It depreciates at a rate of 5% a year. So you got a $15,000 car initially, 5% a year depreciation, so negative 0.05% per year. And again, it's just going to be simple depreciation. Coming up with the model. That's all we're doing. Coming up with a model. And then again, if I was going to ask you how much is my car worth in 2009, well, since I started in 2006, you would plug in 3 for T. If I asked you about 2009, I said how much is the car worth in 2012, you would plug in 6. So we'll get to those questions, but that's the idea with the year, the 2006, the 2000. They don't come into the model, but you do use them if I was to ask you a further question. All right, so let's look at this question. So I kind of did it. Let's just do it again. So you can see the answers over here. So I'll show you how you get those answers, okay? So you deposited $2,200 in a bank account. Find the balance after 4 years. So there's T. So now they're giving you T. You're not just coming up with a model. You're going to plug in T. So for part A, you get $2,200. You get 3% interest. So there's your rate. You're compounding quarterly. So that tells you N is 4. All right, so it's going to be to the NT power. T was 4 again. So 2,200 times 1 plus 0.03 over 4 to the 4 times 4. So plugging this in your calculator is the next thing you got to make sure you know how to do. So if we look at this, 2,200. So 2,200 1 plus 0.03 over 4 to the 4 times, I missed the 4. All right, to the 4 times 4 power. If you do this like this, you're not going to get the right answer, okay? You gotta indicate that the entire exponent is what I want to take. So I'm going to insert some parentheses around the 4 times 4. If you just want to multiply it out and get 16, you don't have to worry about that. But just understand, if you just wrote it the way I did first, you're not going to get the right answer. So this tells you $2,479 after 4 years, so $2,479.38. So that's where that answer came from, $2,479.38. If you change it, $2,200, the next one, you're going to compound it monthly, and you're going to get an interest rate of 2.25. So it's 0.0225 compounded monthly. So you see how the numbers change, but actually it's not going to be, you're actually getting a lower rate for the same amount of time. So actually you get less money. If you see the answers over here, once again, here's the answer to A, here's the answer to B, here's the answer to C. You're going to end up with less money, even though you're compounding at 12. And you're like, well, if I'm taking it to the 12, and you can do this real easily in your calculator. If you just hit second, enter, I just need to change the rates and the end. So the rate was 0.0225, so I'm going to insert 225. I'm going to insert 12. And now I'm going to go here, and it's going to be not to the 4 times 4, but now it's going to be n is 12 times 4 parentheses. So now you're going to see where you get that 2406 from. So 2406.98. All right, and again, you could do the same exact thing for the next one. I won't go into that, but the idea is the same. It's 2% now, compounded daily. So there's your setup. Plug it in your calc. You should get 2,383.23. All right. The next question is a little bit trickier. So looking at this problem, it says in 1990, population of Austin, Texas was 494,290. During the next 10 years, population increased by about 3%. So here's your model. So you got 49,290. So you got your A equals that. And now that you've done this a few times, it should be easy. 3% interest, and you're compounding it each year. So it's to the 1 times t power. Okay? So there's your model. Done. Okay, just like we did the other ones. Now it's going to ask you some further questions. It says, what was the population in 2000? Well, that's basically telling you, if you started in 1990, 2000 would be t equals 10. So all I'm going to do here is I'm going to go 494,290. 1 plus 0.03 over 1 to the 10. I'm sorry. Yeah, to the 10th power. I was getting 1 times 10 is just 10. So 494,290. So 494,290. 1 plus 0.03. All right. Yep. Over 1 to the 0.0. I'm sorry. To the 10. All right, so that's what you should get, and this will tell you the population. So about 664,284. So we're going to just cut it off there. So 664,284. Is that right? 664,284. Okay. So the next thing says graph the function, state the domain and range. So I'm going to flip the page for this. I could graph this function. If I graphed it in my calculator, it's going to be kind of hard to look at. So I'm not actually going to graph it in my I'm not going to worry about what it looks like, but I am going to put my model into my calculator. So my model, once again, just write it here, was 494,290. 1 plus 0.03 to the 1 times t power. So you can put it over 1 still. It doesn't really matter because anything divided by 1 is just the same thing. So 494,290. So I'm going to put this into my y. So y equals 494,290. 1 plus 0.03 over 1. I'm just going to leave it like that. To the t power. I don't have t. I'm going to call it x. So now I'm going to graph it. And I don't really care about the graph. Okay. In fact, I can't even see the graph. And here you go. Yeah. So then I can't see the graph, but it's okay. Okay, I'm not really worried about what the graph looks like. The domain and range, we'll hold off on that. I just want to graph it in my calc. So this is what I want you to do. So now I said estimate when the population was 590,000. Well, that's that. Now I'm going to use my calculator, and even though you can't see it, I'm going to hit trace, And what this just says, now you can see where it says at 0 times 0, 494,290. If I trace and I go to 1, so 0 is 1990, so I'm gonna go to 1. So I'm at about 1 right now. That's 1991. So I'm gonna do this until I get to 590,000, and I'm gonna look at the X number. So I'm at 510,000 right here. So again, this is the year, and this is the population during that year. Again, X equals 1 is 1991. X equals 2 is 1992. So this is what we're looking at. So I'm just gonna keep tracing. I'm gonna go arrow, arrow, arrow. I'm gonna keep going until I get to 590. I'm at 555, 560. So I'm at about 590, right about here. So 589, and then I'm 593. So I'm at 589, and then I'm at 593. So around 6, t equals 6. You see that? So right about there at t equals 6. So again, I'm at 590, right about t equals 6. So what does t equals 6 correspond to? Well, t equals 6 will be 6 years past 1990. It's about 1996. That's all you wanted to do, okay? So it's just an estimation, okay? So let's do the next one. Let's do 9, and we'll finish these notes, okay? So letter A says write a model. You got a bike, $200. This bike is depreciating. The value is decreasing at a rate of 25% per year. So per year is 1, negative 0.25. So here's my model. It says graph the model. Okay, so I'm going to graph the model in my calc. I'm going to do that in a second. And then lastly, it says estimate when the value will be $100. So now I'm going to go to my calc, and I'm going to graph this model. So it's going to be 200. So I'll erase the old one. So 200, 1. You can do plus negative 0.25. You can do minus 0.25. It doesn't really matter. But to the x power. Okay, now I graph it. And once again, you might be able to see it, you might not, but that's not important. The important thing is you know what you get when you trace. So again, the button you hit is trace, and you can see it's highlighted right there. It's that second, it's right to the left of graph. And you see at 0 times 0, you're at $200. So I'm gonna go, okay, when is the price $100? So I'm just gonna keep going until y equals 100, because that's gonna be when the price was 100. So at about 2.3 years. So somewhere between 2.3 and 2.5 years. So we could estimate, at around 2.4 years, after about 2.4 years, the price has decreased to a price of $100. That's how you would do it. So that's just a little bit of a tutorial on that. So now you're going to try your worksheet and see how that goes. All right, have a good one.